Well, hello and welcome to the NEST Climate Systems Hub Climate Tipping Points webinar. My
This
name is Sarah
meeting is being
Bolter
recorded.
and I'm the Climate Adaptation Initiative Lead for the NEST Climate Systems Hub. I am based at the University of Tasmania. So today we're talking about the very challenging topic of climate tipping points. It coincides with the release of the Hub's new fact sheet, delving into the latest thinking around tipping points for Australia and how decision makers might consider them in their work. And we'll pop a link to that in the chat. We have two fantastic speakers today who I'll introduce as we go through the webinar. But first, I would like to acknowledge the traditional custodians of Australia. I'm joining here today from Ngunnawal country, and I pay my respects to their elders, past, present and emerging, and would also like to extend my respects to all Aboriginal and Torres Strait Islanders joining us today. We recognise the important role traditional knowledge plays in understanding Australia's climate. We know that you are dialing in from across Australia, so please take a moment to think about the traditional owners from where you are joining from. Just a few housekeeping points before we begin. So first, please make sure that your microphone is muted. Letting you know that this webinar is being recorded, and we'll make that link available on the NEST Climate Systems Hub website in due course. We do encourage you to ask questions, and this can be done at any time by typing them into the Q&A function. We will try to address as many questions as possible live and later in the session, but I encourage you to get in early as we don't always have time to answer, to address all questions. So let me just very quickly set the scene for our webinar series. A little bit of background on the Climate System Hub webinar. If this is your first one, welcome. These webinars are designed to provide an opportunity for learning and interaction with a broad range of topics and experts. We've had a great range of presentations through the year, and today is going to be another one. You'll find the past recordings available on our website, and then, as I said before, we'll make this one available in coming days. So let me introduce our first speaker, Dr. Michael Grose. Michael is a climate scientist at the CSIRO in Nipaluna, Hobart. His research focuses on our changing climate, mainly in projections of future climate change for Australia and the region, but also in attribution of past change and the translation of climate change information for decision making. He led a joint workshop on tipping points for Australia last year, and so Michael will now take us through the science and thinking of tipping points. Thanks very much, Michael.
Thanks very much, Sarah, and thanks to everyone for joining. Can I just check that the screen looks full screen and all set to go and you can hear me?
Absolutely.
Great. So as Sarah mentioned, I'll be mainly reporting back from a workshop that was held, bringing together a lot of experts in various aspects of climate tipping points and supported by a lot of agencies. So all their logos are at the bottom there, including NEST's Climate System Hub was a supporter, but a lot of Antarctic agencies, Bureau of Meteorology, CSIRO, Australian Climate Service, and CLEX as well. So it really was a coming together of a lot of great experts to kind of talk about this topic, because it is a hot topic. It's a super hot topic. So here's just a snapshot of a few headlines. They're very dramatic headlines. These come out every once in a while when there's a new paper, when there's a new study, when there's new commentary. There's often a lot of dramatic media attention with catastrophic kind of words like catastrophic, words like day after tomorrow, words like, there's an article just today talking about forced migration from the coasts and so on. So it's absolute catnip for headline writers in the media, and understandably so. While the tipping points concept is not new, there's been a huge increase in attention in the last couple of years, since at least 2023. I've noticed, but it's not a definite kind of date there. So the question is, well, what does this mean? What does it mean for the world? What does it mean for Australia? How should we think about this? How should we talk about it? So we held this workshop. It was in actually late 2023, so it's a little while ago now. We had over 60 participants, and we had a report that was launched at a public event at the AMOS conference in 2024. There's the cover of the report on the right, and there's an ad for the lecture that was held in 2024. And there was, as I mentioned, expert teams in oceans, in ice sheets and sea level, sea ice, ecosystems and carbon cycle. And a special thanks to Professor Katrine Meissner, who's an expert in tipping points in Australia, in New South South Wales. She was a key person, and also a great New Zealand guest, Nick Goddard, who's an ice sheets expert, but not to downplay all the great experts from around Australia who participated. So technically, or kind of conceptually, what does tipping mean? So it means kind of a change of state that is self-perpetuating through things like feedbacks, it's abrupt, and it's irreversible on climate timescales. So there's certain elements in the Earth system which are known as, which could qualify as being tipping elements, and they can reach a tipping point and they change from one state to the other. This little animation kind of shows conceptually what you might kind of consider a tipping point. From one state where it's relatively stable, conditions change, and then we move from one state to another state. And this can be seen as an abrupt change in a time series in the right-hand side. And it's very much now into a new stable state. It's very different from where it started from. Don't worry if you can't read all the words there. It's from the Dutch Met Service, but I thought it was a nice kind of animation to show. Where are Earth's potential tipping elements? So there's tipping elements in the ocean, mainly the overturning circulation. The famous one is the Atlantic Meridional Overturning Circulation, AMOC, but there's also the Antarctic Overturning Circulation and others such as in the Labrador Sea. There's potential tipping elements in our ecosystems and carbon cycle. So the thawing of permafrost, the Amazon rainforest dieback, boreal forest dieback, and coral reefs. And there's potential tipping elements in the ice. So the Greenland ice sheet, the Antarctic ice sheets, both west and east. There's glaciers, high mountain regions, and sea ice. We've put a question mark there. Is that truly a tipping element or not? When, in terms of future projected climate warming, could these tipping elements tip and change state? We know they have changed state in the past. We've got paleo evidence that we have seen changes in the kind of state of each of these tipping elements. This was quite a notable and well kind of viewed review that was published in Science. And this was their assessment based on kind of expert judgment of the level of extra global warming since pre-industrial that could make these tipping elements vulnerable to being triggered or tipping. And this was kind of presented as a rule of thumb. And this kind of really illustrated that perhaps 5 or more are vulnerable now or very soon to undergoing tipping. But some are much further off in terms of much more global warming would be needed. And some of them have very, very large error bars on them. However, we should really note that there's a bit of nuance to exactly what those potential triggers are. It might be a warmer climate over a period of time. It might be just a peak episode of warming, no matter how long it lasts. It might be warming and drying, such as for the Amazon rainforest or others. And these triggers might be committed before the tipping occurs. We might be on track to trigger them before we can even stop them. And it's also possible that we could trigger a tipping point, but we don't know we have until afterwards. So just a quick note on the overturning ocean circulation tipping elements. So of course, AMOC, the day after tomorrow, that's the most famous one. It's a whole research area in and of itself, and a lot of important and valuable work is done within Australia, looking at ocean currents, especially the Southern Ocean and Antarctic overturning circulation. Here's a schematic from a recent scientific paper kind of illustrating the proposed flow and effects from a shutdown or dramatic slowing of the AMOC, and how it would then lead to ongoing or kind of further changes to the whole northern hemisphere and southern hemisphere by altering ocean currents and also atmospheric circulation. Direct effects to Australia could be enhanced warming in contrast to the dramatic cooling of Europe, and perhaps offsetting the drying that we might be experiencing at that time if it gets triggered. It would then of course have huge indirect effects. The immense disruption that it would cause to the North Atlantic region would then obviously affect the whole world, and then therefore to Australia. A quick note about sea ice. So there's various technical questions, and the sea ice work being done in Australia and elsewhere is addressing this, but there's debate whether it really should be described as a tipping element. And if so, just the winter sea ice, just the summer, just the Arctic, just the Antarctic. But Nevertheless, whether it is technically a tipping point or not, a major reduction in sea ice extent, especially a rapid decrease, which we have seen, as you can see depicted in that blue trace on the right. Antarctica has seen a dramatic kind of decrease from about 2016 onwards, compared to the just gradual, steady decline in Arctic. That's a very interesting finding. This has major implications for Australia. It affects Southern Hemisphere weather patterns, of course, and it then can affect other tipping elements, such as the vulnerability of ice sheets and more. Biosphere and carbon cycle tipping elements include those ones I mentioned before: permafrost thaw, Amazon, boreal frost, iceberg, coral reef, and die-off. A related but also extremely important kind of effect here is whether or not it's a global climate tipping point. Local ecosystems can reach tipping points, and you can see things like ecosystem collapses, where a forest might turn to a grassland, a coral reef might go to a more soft coral state. These kind of tipping points in the local ecosystems are really important, whether or not they are global climate tipping points. And three particularly vulnerable ones in Australia are alpine, coral reefs, and southern forests and fire regimes, and there's also other coastal ones such as kelp forests. I'm going to spend a little bit longer on this major one, which is ice sheets. So depicted here on the right is satellite measurements depicted as a visualization of where ice sheets are currently losing mass. Greenland and West Antarctica especially, but also some areas in East Antarctica. We know they're losing mass, and there's a lot of changes going on. And ongoing loss is part of the sea level rise budget, and that's what informs our estimate of likely ranges of sea level rise, those processes continuing, along with all of the other aspects of climate change, such as thermosteric, warmer water is larger, it will cause the sea levels to rise, and other components as well. What makes ice sheets a potential tipping element? Well, there's two key processes that have been proposed that are topics of hot debate and discussion, and very rightly so, because they're very important. Possible processes of marine ice cliff instability and marine ice sheet instability, and ice shelf instability as well, sorry, otherwise known as MICI or MISI. Once these could meet all these three categories, the collapse or this instability could create self-perpetuating change. Once started, instability and collapse set in motion and hard to stop. Abrupt, it could move from a high ice state to a lower ice state relatively rapidly in a matter of decades to centuries, and is effectively irreversible, committed for a very long time. Ice sheets take tens of thousands of years to regrow through snowfall. And the effect of that is a more rapid sea level rise. And here's a cross-section of some of the proposed instability processes, kind of looking as a cut through each ice shelf and each ice cliff. And you can see it involves, collapse and instability of the ice through warmer water underneath, as well as warmer air on top, and the ice kind of undergoing various kind of different processes that makes it more unstable. How much sea level rise and how quickly could this is thought to be lead to? Here is the output of an exercise of structured expert judgment based on the current evidence base. So this is not analysed in the way that other sea level rise projections are. This is kind of getting the experts together, looking at the evidence and having a structured expert judgment exercise. They noted that nominally it could be something like 2 metres by 2100, which you can see is dramatically higher than the ranges of likely change, or even 5 metres by 2150. However, importantly, these are drawn as dashed lines and the confidence is given as low. And perhaps even rather than just describing as low confidence, perhaps some phrases people are using more now is unknown likelihood. It's possible, can't be ruled out, but we actually don't know how likely it is because we don't have enough understanding to kind of put a likelihood on it. And I just wanted to kind of highlight some of the latest evidence coming out in this area. This is a paper that just came out yesterday, I believe, from a group within Australia, looking at the observation-based look at future sea level rise out to 2050, and this very much supports the process-based projections in IPCC, so that's a good confirmation from those two lines of evidence. They also had a look at these low likelihood, high impact storylines, these low confidence storylines, and these remain very well above both, confirming that these kind of scenarios of instability and ice sheet collapse leading to higher levels of sea level rise aren't kind of locked in yet, but they represent a change in the processes, and perhaps at the moment aren't looking like they're that plausible before 2050, but it doesn't mean you can rule them out to 2100 or to 2150. Also in this paper, they lay out the by region, including the ranges of likely change and these high scenarios. And you can see Sydney there in the top right, which is similar to the global average in terms of the likely range of change and those high scenarios. I just thought it was worth perhaps dwelling a little bit on sea level rise and these depictions here. So I think the fundamental aspect that a lot of sea level rise is now committed through ice sheet collapse and ice sheet decrease is an incredibly important factor on its own. And the fact that sea level rise could be very rapid, we know in the paleo evidence that it has risen rapidly in the past. If you can imagine Sydney at 2050 with a few centimetres, kind of perhaps 15 centimetres more sea level rise, that's going to start having effects already. By 2100, we're starting to see perhaps even a metre under these likely scenarios under high emissions, or half a metre under a low. And these wildcard scenarios say that even more can't be ruled out. So what we'll be seeing is increased high sea level events, floods and inundation, erosion, eventual loss of sand on beaches. This will make places less attractive to live. Insurance will become more expensive. Real estate prices might drop. Some areas become underwater. We might just have to retreat for them or spend a lot of money on seawall defences. Pipes and sewers and other infrastructure are affected. And at what point does incremental adaptation reach a limit and we just kind of move out of these areas? Now imagine it for poor low-lying areas around the world, such as Kiribati or Bangladesh, and just what that would mean there. And this isn't even with those high-level scenarios having to be true. And then also imagine that this is now committed for thousands of years. We possibly will get 1 to 3 metres, possibly even 5 to 10 metres eventually over thousands of years. What would people in the year 4000 think and look back to us and say, why did you commit us to be living in this world with metres more sea level back then when you were emitting all these greenhouse gases? Anyway, I thought it was worth kind of thinking about that. So what would triggering tipping points, a major one or a set of major tipping points, look like for Australia? Well, it would obviously have direct effects, indirect effects, and this would cause cascading impacts to the whole system. In its worst cases, pushing past human system thresholds in a lot of different categories in terms of finance, conflict, instability, migration, and so on. And here's a mapping of kind of the tipping points and how they would affect migration from an international report from 2023, showing that climate change, extreme events interact with these different aspects, including agricultural production and social cohesion, to affect migration and create things like refugee crises. So these kind of worst case scenarios of hitting various thresholds are very scary, but also there's this idea, it has to be very strongly emphasised that tipping isn't inevitable, it can be prevented, we can mitigate impacts, including there's this concept of positive tipping points as well is important to consider, where action creates more positive action and you get cascades in a positive direction as well. Noting what we don't know a lot, so there's a whole lot more to learn. We need improved paleo evidence, observations and models to understand various aspects. And a recommendation of the workshop was to support ongoing our world-leading research in Australia, including on Southern Ocean and Antarctica. And how should we start thinking about this? Well, it's a difficult space, mostly unknown likelihood, very high impacts, but we can't actually ignore it. So we need to raise awareness and acknowledge that they are there. And what are our possible responses? Well, mitigating and limiting further warming is obviously the highest priority there. And start thinking through what adaptation is possible or recommended given this. And the one conclusion we could come up with is that major new infrastructure with a very long lifetime should use the highest sea level allowances. Why build an airport at sea level nowadays? But the main recommendation is to start considering tipping points using appropriate risk management approaches and thinking about them in a smart, clear-eyed way. And that's where the NESP has produced this fact sheet, starting thinking about adaptation, and experts like Ben Newell are thinking about how we should think about tipping points in a cohesive risk management framework. A couple of quick thoughts. The term grabs attention, grabs headlines. It comes from a book about 20 years ago. The word just grabs attention. This can, in some senses, perhaps be a distraction from other important topics. It focuses on aspects where we've got deep uncertainty. It may, in fact, distract from confident aspects about climate change and the challenges we know we face from the likely ranges of change we do have to cope with. It can scare people and create urgency. Headlines about catastrophe get attention. This may not actually motivate action. It may just make people feel kind of alarmed. It can confuse warming limits with system behaviour. If we reach 1.5 degrees, game over. It's like, no, that's just a kind of policy, a goal. And any one aspect of them are important, even whether or not a tipping point meets all three. So, for example, committed sea level rise, the irreversibility of sea level rise is incredibly important, whether or not ice sheets are technically a tipping point. And how can we think about and use this for policymakers? That's a kind of open question, I think. And just to finish off, I was just going to say, I'm really excited to be partnering with a new project under the NESP Hub, which is called Uncharted Climate Futures, which is taking a wide view on potential futures that are currently not well described in projections, focusing on these 4 areas that with a very strong basis for addressing them right now, to do with different scenarios that we haven't thought about before, and also different model responses that aren't in our regular set of modelling, plus synthesising and translating this with other things, including tipping points. But I think this is really getting to the heart of thinking about the range of possibilities that we don't usually consider in a more coherent way. But with that, I'll hand over to Ben. Thanks very much.
Thanks, Michael. Fantastic summary there of the science, a very rapid rapid way. So I'm looking forward to the questions that are coming in now. So don't forget, we'll come to questions at the end of the presentations. But first, I'd like to welcome our second speaker, Professor Ben Newell. And Ben is Professor of Behavioural Science in the School of Psychology at UNSW Sydney. He's the Director of the UNSW Institute of Climate Risk and Response. His research focuses on the cognitive processes underlying judgment, choice and decision making. His role in the Institute is to drive an interdisciplinary research agenda, bringing together expertise from behavioural science, climate science, economics, law and governance to address the risks and opportunities of change. So Ben, thanks very much.
Thanks very much. Well, thanks very much for the invitation to speak at this webinar. Thank you to Michael for that fantastic presentation. It's going to be very hard to follow that. I just want to quickly acknowledge the Bedegal people, the traditional custodians of the land where I'm joining from here in Sydney. So my role here is to sort of think about how climate tipping points are communicated, whether or not they're a useful concept, how they might be used in our risk management and planning framework. And this is obviously building on the excellent report that the NESP I've put out. And I thought I'd just use this graphic from the report because I think it's a nice way of just thinking about tipping points as Michael's just gone through. So this graphic that uses the tower block, a Jenga kind of game, and shows that you can start to build up these different elements, these different factors, and then at some point the whole system collapses. It reaches this we've all played this game. You see it, it's about to go, and then suddenly it's gone and the whole thing tips over. Now, whether that analogy is actually the right one and whether that's a useful way to really think about these tipping points is something I'll come back to right at the end, because I think it is crucial for that question of how policymakers might actually use this information. So as Michael and Sarah both indicated, this report builds on a previous report that CSIRO put out last year. And I took this quote from the report because I think it's a useful place to start for the thinking, the psychology and the communication of tipping points. So as they acknowledged in this previous CSIRO report, the uncertainty in the sixth assessment through low likelihood, high impact outcomes. But they say that, however, given deep uncertainties, we propose that the term poorly understood likelihood or high impact outcomes is perhaps more inclusive and appropriate. And when I participated in an event last year that Michael was involved in when this report was launched, we had a discussion on a panel then about perhaps the term poorly understood is not a great one because it already starts to build a sense that, well, we don't really understand what's going on here. If you don't really understand what's going on here, then, should I be listening to you? Should there be these things, should they be important and should we be focusing on them? And so, as Michael suggested in his talk, there's been perhaps a bit of a shift to unknown likelihood rather than poorly understood likelihood, which I think is better, but it's still it really communicates that we don't know what's going on here. And the problem with that, I think, and this is a quote from a recent review looking at the psychological impacts of low probability, high impact events, is that people just have a lot of difficulty in thinking about these sorts of events. So as this quote illustrates, so the events with very low a priori probability but very high impact shape our lives to a significant degree, both on individual as well as a global level. But unfortunately, we just have difficulties understanding and processing the prospects of such events, leading to potentially idiosyncratic behavior. And this review goes through a few of the factors that lead to those difficulties and why we have problems sort of processing these prospects. I won't go through all of them, but I did want to highlight a couple at the start here that sort of come from the basic psychological literature on risk communication or risk understanding. One of them is that just simply the way you frame different information has an influence over the interpretation that people have and the behaviors that they then might adopt. So this is not about a tipping point, but this is about, just your risk that your home might get flooded. Two ways of communicating that information. One, every year there's a 1 in 100 chance that your home will be flooded. A second, over the next 40 years, there's a 1 in 3 chance that your home will be flooded at least once. Statistically, those two ways of communicating that risk are identical, but psychologically, they're really quite different. In the second format, 40 years might be a time frame that you're thinking about living in a house for, or a mortgage that you're repaying or something like that. It's a bit more of a concrete way of thinking about it than a 1 in 100 chance. And that indeed can influence people's willingness to take out insurance or think more carefully about actions that they might take to protect their homes. So that's a simple framing that can change our perception. A second one is this difference between what's called describing risks versus experiencing risks. So in the lab, we can actually simulate the way in which people learn about risk information. So one here, every year there's a 1 in 100 chance that your home will be flooded. That sort of description way of thinking about it can lead people to overinflate or be more concerned about something. Whereas if you experience this, and my little graphic here, hopefully this is working on the screen, you can think about this unfolding over time, and just one of those many, many years over time, you see this event. And that way of experiencing those risks, and we can, as I say, simulate this in simple lab experiments, can lead to people kind of underweighting that risk. And so dealing with that different tension of how you describe risk versus how people experiencing them leads to what I think is one of the big challenges. And I'm going to talk about 3 challenges for tipping points. One of the big challenges, which is the kind of importance of building and maintaining trust when predictions and projections about tipping points are maybe outside of or not congruent with our experience. As Michael said, the timescales here are very, very long. They're probably going to be beyond most of a single person's lifetime. And therefore, having experience which kind of converges with the information that we're giving about these tipping points is potentially an issue. Now, I did want to make a quick analogy to an example that I think it bears some relation to this. Back in the year 1999 and slightly before that, there was a huge concern around the world that all the computer systems all over the globe were going to fall over, and there was going to be mass panic, and everything was going to stop as we ticked over to the new millennium. And this was called the Y2K bug. For younger members of the audience, it may be the first time you've ever heard of it, but for people of my generation, this was something that we were really deeply concerned about. And then, as this headline from a BBC News site at the time shows, the bug failed to bite. Nothing really happened. And there was a question then, and it's still a little bit unclear as to whether nothing happened because there was lots of preparation and people, altered all lines of code throughout all of their programs to make sure that nothing would happen, or because we'd overestimated the risk in the first place and it was never actually going to be a challenge. And I think that there's that when we're communicating these sort of tipping points, these major changes, there's a danger there of this sort of asymmetry in the way that the risk gets communicated. And if I can stretch the analogy a little bit longer, or a little bit more thinly, perhaps, it's a bit like, saying, well, we need to build a flood wall. You build a flood wall extremely high, and then nothing happens. And people say, well, you said it was going to flood, this thing was going to flood, and nothing happened. Well, nothing happened because you built the wall high enough, right? You don't get any thanks for that. People just say, well, you said it was going to be terrible, but nothing actually happened, versus a situation where you build the wall too small, everyone gets flooded, and then you get accused of, well, why didn't you build a bigger wall? So it's a kind of it's a difficult space for communicators, for scientists to get involved in, because they're sort of damned if you do and damned if you don't. And that maintaining that trust and building that trust is a real crucial issue. This graphic is supposed to illustrate, the implications or the difficulties that one can have when that experience over time and the explanations that you give or the understanding that you have for these events don't perhaps gel. This is adapted from a paper by Lacey and colleagues who were looking at the interaction between climate scientists and policymakers in communicating science. And the idea here is that the level of trust that the public or a policymaker might have in a group of scientists depends on whether the information that they're getting gels with the experience that they then have of these events unfolding. So the blue line at the top is an ideal situation where this is what we think is going to happen, and this actually works out to be the experience that we have. The red line is a sort of crash and burn, a bit like the Y2K bug, where you told me this thing was going to happen and then it didn't, and so now I'm not going to trust in you anymore. I'm going to ignore your information. And we can think of different variations of that in between, where we kind of admit mistakes, or we know that we've got limited information. We say it's poorly understood or it's unknown, and hopefully, even if things don't turn out exactly as we experience, there's still a maintenance or a rebuilding of that trust. So this is kind of hypothesized relationships about how trust might develop. And for that trust to really to be strong, we need to look at, well, what are the factors that underlie trust in climate science and climate scientists? This is a paper that we just published earlier this week, led by a research associate at ICRR, Omid Ghasemi, where we looked at trust in climate scientists and scientists in general in a large global study with about 70,000 people in it. And this is an article from The Conversation that you can go and read with some more details, and the paper itself is there. But what did we do in it? Well, we looked at the difference in trust between climate scientists and scientists in general across the world. And what this plot is showing are the areas where climate scientists are trusted more in the sort of greeny color, and scientists in general are trusted more in the purpley orangey color, purple color. And what we found was that in most places, with a few outliers that you can see, in most places, scientists in general were trusted more than climate scientists. There was a kind of a gap between the trust in scientists and the trust in climate scientists. And the reason I'm bringing this up in this context is because clearly you have to think about what are the underlying drivers, what are the motivating factors there that are going to change the way that people are hearing the information that you're giving you. What's the message that they're hearing from a climate scientist when they're talking about tipping points? And another part of the analysis that we saw, maybe some of you might have already anticipated this, that political orientation, or the way that you identify politically, does infuse your trust in climate scientists. So here you can see that political orientation was associated with higher trust in climate scientists in a lot of these countries, showing the blue here in the left leaning. So again, understanding that audience when you're trying to communicate these complex issues is an important part of the story here. The second tipping point challenge is, I think, again, one that Michael came to with the unknown probabilities, or the need to think about all of the other information that we have to incorporate when we're thinking about the deep uncertainty that we're trying to explain. And one technique that has been used to try and do this, to try and get over the difficulties with not having precise estimates, is to use what's called storylines. And this is a thing that we covered in this briefing note that was done with Gab Abramovitz, Andy Pittman and Angela Kaplesh at the ARC Climate Extremes Centre of Excellence, where we were focusing particularly on how you work with uncertainty in climate planning and adaptation. What are the limitations of climate models? What are the limitations that we have in projecting these kinds of different futures? And the idea behind emphasizing this is that we know that we can be very precise sometimes, but that precision doesn't necessarily mean that we're also going to be very accurate. So this graphic here is just trying to illustrate the difference between being highly precise, all the darts are in the same place, but they're not in the bullseye. so they're not necessarily accurate, versus a situation where we might have very high precision and high accuracy. We're right in the bullseye. And I think from what we've heard and what the briefing note is about, we don't have yet that high precision for tipping points. So therefore, we need to augment the explanation of them with other sorts of techniques. And as I just mentioned, this other sort of technique is something like these storyline type approaches, which acknowledge the deep uncertainty, acknowledge that we can't tell exactly where we're going to be in these range of future possibilities, but where we can use and rely on lots of other sources of evidence, the kind of expert elicitation that Michael alluded to in his talk, to build out what these plausible futures might look like, and then try to help inform policymakers and the public about what these futures will be and how tipping points could be incorporated into them. And an example of that, not again with tipping points directly, but with thinking about flood risk, come from this paper, which Michael contributed to, and also with colleagues led by Tanya Fiedler, who's a lecturer senior lecturer in ICRR with us in Sydney, focusing on how you actually do integrate that kind of information. And in this case, for thinking about the physical climate-related financial risks, and this is actually to inform people who are trying to understand the impending risk to their organization, their businesses, the mandatory reporting on climate risk that is becoming more and more prominent because of the change in legislation, and how you might actually do that. And by building these narratives and testing them out, the reason I've got this little picture of a brain with cogs in it is because I think from a psychological perspective, these kinds of ways of doing it just gel more readily with the way that we tend to process information, with the way that we try to build our own understanding of what's going on around us that isn't just based on pinpoint probabilities and precisions. We can also build that out into even broader types of scenarios that include elements of socioeconomic pathways. And I think this comes back to this point about, are tipping points just about physical climate, or are they tipping points in other socioeconomic aspects of society? This is a slide taken from a piece of work done between the University of Exeter and the one of the university superannuation companies or pension companies in the UK, where they were thinking about possible different scenarios under which you might make decisions about where you drive your future investments. And again, this is building into things, not just how a physical climate tipping point might happen, but how that might cascade into other social tipping points as well. And I think the last 2 points I'm going to make, one is that yes, we do have the opportunity to take action to try and precipitate a social or behavioural tipping point. We talk a lot in behavioural science about taking actions at a kind of individual level. So, improving people's choices of more sustainable food or more sustainable power. But all of those individual level changes and individual agents can lead up to what we think of as a system level change. And this is a graphic a little bit like the one that Michael showed. It's not animated, but you get the same sense that the ball is rolling and then it reaches a tipping point and things change. Here it's trying to trigger positive tipping points using agents of change. And just as a sort of one little thought bubble about this, I've been talking about the fact that if Australia and the Pacific get to hold the COP meeting, COP31 in 2026, which is a possibility, then that maybe could act as a trigger, a real social tipping point for changing in behaviour and awareness of climate. The final point, though, going right back to the start where we looked at the Jenga game and the idea that everything's going to collapse, is just going to this paper that was also on one of Michael's slides about whether tipping points, I think a key challenge is whether they're a distraction or a determinant of action. And sort of tying it together, this is a quote from that paper where they talk about the fact that if people talk about 1.5 degree as a benchmark tipping point, that something is going to happen at 1.5, and then there isn't an obvious tipping point at that nothing materializes, then that can lead potentially to a reduction in scientific credibility. So again, it's that balance between saying, yes, these are things that we need to pay attention to. They're not going to unfold like a Jenga block being taken out but that doesn't mean we ignore them. We don't know precisely what the probability is, but that doesn't mean we ignore them. It's a real challenge, and I think that's why having this opportunity to discuss it and have some really deep thought about it is extremely useful. So thanks again to NESP for giving us this opportunity, and I will finish there. Thank you.
Great, thank you, Ben. Fantastic. I mean, thank you both our speakers. What an amazing couple of presentations, really thought-provoking. So I'm just going to try and sum up what I think I've heard, and you can pip in if you think that I'm not right. And so I think, you know, what we've heard from you, Michael, is that this is an area of very rapid science or knowledge development. And we've certainly identified that there are elements in the climate system that could tip, but using some of Ben's language, we don't yet have high precision about when or how much that might happen. I think one of the things that might be a little bit of a misconception, and it goes to your point, Ben, about the Jenga game, is that tipping points are not the Hollywood scenario. No, we're not suddenly going to tip into a state where, you know, the Statue of Liberty floats away or something. But I think an important one for decision makers to understand is that, as you said, Michael, we're committed to a certain level of sea level rise, and ice sheet melt. Certainly there's some tipping points there that could increase that rate of change. But when we talk about rapid change to sea level rise in that context, it's still thinking maybe 50 years, 2 or 3 generations. And so, you know, that has an influence over the kinds of decisions that you might take that into account. But I think it also creates a moral challenge for the future where tipping points are sort of, you know, it's something where we as a society have to make a moral choice around you know, our efforts to reduce emissions to make sure that we're not committing the planet to maybe 10,000 years worth of change. I think really importantly from your perspective, Ben, you know, you highlighted that trust is important in climate science, in that climate science policy relationship, and that tipping points, in talking about tipping points, it's a fine line in communicating that between avoiding overreaction, but also scaring people so much that nothing happens. And I think that is a really important point in terms of thinking about how we talk about tipping points. And, you know, the media it makes terrific headlines, right? And I think, Michael, you pointed out to us there was a tipping point headline just this morning in the Guardian paper. It's one that tends to, you know, in the climate science, it's one that creates headlines. Fair summary, hopefully. Great. So we do have a bunch of questions in the chat. Oh, and thank you. There's the fact sheet that both Ben and Michael referred to. So we'd love people to take a look at what we did there. But Michael, we've got some questions here that are really about clarifying some of the science. So the first one, do tipping points imply runaway climate change scenarios driven by positive feedback loops as distinct from incremental warming of the atmosphere?
So there is some technical differences between and we do need to be really careful about the wording here. So there's abrupt changes, which is just about how they can happen abruptly. Not all abrupt changes are linked to technically a tipping point. We may see, say, an abrupt change to the behaviour of the El Nino Southern Oscillation. That has happened in the past, could happen again, but then that can change back. It's not necessarily a tipping point where it changes irreversibly. Then there's tipping points which meet those 3 criteria: irreversible, abrupt, and self-perpetuating. So some of the aspects of self-perpetuating are due to feedbacks, exactly. So when a change is self-reinforcing, that's a form of positive feedback. Runaway climate change is often talked about in terms of runaway warming, like has happened on other planets as well. Like where, you know, I think it's Venus ends up being extremely hot because you do get very strong positive feedbacks and warming becomes runaway. There's also a lot of other terms in this field like climate surprises, and so on, and then black swan events, all these kind of things. And all of these concepts are all important and relevant, and there are technical differences between them. But I guess the broad point is, yes, we're talking about changes that are due to abrupt changes, due to feedbacks that go beyond or are different in nature than what we kind of see through incremental changes to processes. Yeah.
Yeah, I want to come back to that idea of terminology in a moment, but first, just a quick clarifying question for you, Michael. Is the East Antarctic tipping point lower bound still estimated to be about 4 degrees?
So the East Antarctic ice sheet is much larger than the West Antarctic and contains a lot more ice, and is seen to be kind of slower to respond to climate changes because it's such a bigger thing. There's a lot of uncertainty towards certain key ice shelves in East Antarctica and how vulnerable they are to becoming unstable and collapsing. So there are a lot of those deep uncertainties. And I actually can't say if any new literature has put a lower bound to any kind of potential tipping behaviour of the East Antarctic ice shelf lower than 4 degrees. I'm not sure. Someone like Steve Rintoul here would be able to talk about that. They've been doing some new research on some of the key ice shelves and glaciers in the area. But regardless, I mean, it is a big source of long-term sea level rise as that starts to lose mass.
Yeah, great, thank you. And so probably bringing you in on this conversation as well, Ben. I mean, you touched, Michael, on concepts, and I guess I'm thinking, you know, does the concept of tipping points, has it gained almost a bit of an image problem? Is it a helpful term to use? I don't know who wants to have a crack at that first.
I mean, I'll have a go. I think you know, as both of us mentioned in the presentations, that it certainly grabs attention. It gets people talking, it gets people thinking about climate and what they might be able to do. I think the paper by COP that both Michael and I have referred to is really quite a challenge, and you know, is saying it's perhaps taking valuable media attention away from the things that we can take action on. I'm less persuaded by their arguments that fear and doom mongering might turn people off. I think that the jury is still out a little bit, but if anything, I think maintaining a little bit more focus on perhaps quite extreme scenarios is useful. It does gain people's attention. Obviously, you want to augment that with information about what they can do, and that that isn't lost in a sense of, well, it doesn't make any difference. My individual action is minor and won't get anything done. And I think maybe, you know, to go to the two uses of the tipping point, and it is that you can tie those two things together, right? If you want to avoid the really big negative climate tipping point, then you have to do lots of individuals have to do lots of things to reach that social tipping point. And again, the social tipping point isn't a Jenga tower either, but it is something which you need that momentum in order to get over the hump and get that that action trending in the right direction. So personally, I think, you know, given the noise that is out there, any opportunity to get discussion about climate into the everyday discourse is probably a good one. I think that's probably where I end up. Whether the scientific efforts, how much they should be focusing on reducing the precision around when these tipping points are going to happen versus things that are perhaps a bit more proximate, I'd leave that to the actual climate scientists to comment on.
I'd just add to that I think if you've got the opportunity to talk in a full sense about the range of possibilities, including these chances of the high end of risk, including tipping points, but other sources of high end risk, then that's great. We can think about all the ranges of possibilities. If something is being narrowed down to a single message and it's just focused on a single aspect of that range of possibilities and acting as if it's excluding the other possibilities, that's more of a worry. And I guess that's where our communication to media needs to be very careful about giving a nuanced message and a complete message rather than the opportunity to write a flashy headline and be misinterpreted. But I also think it's more of a social science question, so I'm not qualified to answer, but I have heard people make the case that even the movie The Day After Tomorrow is kind of, you know, off as it was with how fast it happens and so on. Like as you were saying, Ben, some people have made the case that's still drawing attention to issues, and there's some grain of truth in there somewhere. So it's still kind of for the good. I'm not sure, but I think it's an interesting question. Yeah.
Yeah. I mean, I think that there's actually not a huge amount of research that's looked directly at this link between tipping points and the impact of that on people's behaviour and willingness to do things and their overall understanding. There's a few references called out in that COP paper, but I don't think it's a huge literature yet. It's an interesting one to get into. Maybe something that we should be collaborating on the new project that NESP is running. I think that'd be fun.
Yeah. So Ben, the question that's come through is, how do we make a difference and make people take notice and react and mitigate, emissions and drive behaviour change?
It's the $6 million question, right? I mean, I think the good thing is that, I mean, another part of that question was, because I can see it in the chat, was about people still being in denial, and I think that the number of people who are in denial is reducing. I mean, there's different types of denial. There's denial as in climate change isn't a thing that is happening at all, or that's kind of implicit denial, which is, yeah, it's happening, but there's nothing I can do about it. But I think what increasing numbers of large-scale experiments and reports and surveys and polls are showing is that the number of people who think climate change is a really major concern is increasing. It's increasing worldwide. There are increasing numbers of people who are saying, yes, I would be willing, for example, to give up some portion of my income to address climate action. Lots of 90% almost of people saying, I think governments need to be doing more to address climate change. And another key finding that comes out of those sorts of large-scale reports is that there's a disconnect between the level of support that people themselves give versus their perception of how many other people would share that same view. So there's this sort of perception gap between what I think and what I think other people think. And to give you an example, for these reports that have looked at, this how much of your income would you be willing to donate for climate action, there's about a 20% difference worldwide in the people that say, yes, I would do that. It's about 70%. And then you ask them, what proportion of people do you think would do that? And they say about 58%. So I think we do need to be we need to be more aware of the fact that this is an issue that more and more people are concerned about, and that is something that needs to be done. I'm not saying that means we should all be. It's obvious that we're all doing enough, but I think the opportunity to have these kinds of conversations, to advocate, there's obvious lifestyle choices that some of us are able to take. Not everyone's able to take those. In some ways, it's still kind of a luxury to be able to think about actions that one can take to address climate. But I think that the message is getting through. I think there's now discussion about solutions and what's the right action to take, both individually and nationally. But I'm more optimistic that there is certainly more awareness and more concern than there was 15, 20 years ago. This idea of climate change being psychologically distant is not really supported by the data anymore.
Amazing. So we need to have more faith in our fellow human beings. That's my take home from that. I like it. So Ben, you talked about trust, but I'm actually going to start this question with you, Michael. And so this question is talking about the need to build trust. And the question is sort of saying, well, can we say something about the success of climate projections from previous decades? So they want to know, how accurate or how close have climate projections been over the decades of doing it to what we're seeing? Like, how much confidence should we have in our science?
Yeah, so there was some good content that I contributed to in Chapter 1 of IPCC AR6, looking back at the earliest projections of global mean surface temperature and also regional temperature as well. I'm not aware of the literature on sea level, but that may be similar. And even the earliest studies as back as far as 1970 had a pretty good handle on the rate of global warming that we would expect given a certain amount of emissions. Some of the human scenarios they played out in the 70s and 80s didn't come to pass because our emissions, they couldn't predict the emissions, but their analysis of the likely response to those emissions was pretty good, really very good, up until the first assessment of the IPCC and further on. I mean, the one key number here is so-called climate sensitivity, how much the globe warms, given a doubling of carbon dioxide. We've had, ongoing debates about that, but it's all centered around a similar range that's been there for over 100 years. So we've had a pretty good idea of some of the basics with a big, spread of the arrows in the target for quite a while, and some of the projections have been really very good. And my part on the regional, even in the first assessment report from the IPCC, regional temperature change, more over continents than over ocean, more in some areas than others, larger increase over the Arctic through polar amplification. We've had a pretty good idea about this for 40 years.
Yeah, that's great. And Ben, do you think that it's important that that this be demonstrated to actually build that trust? Is that part of the story?
Absolutely. I think that's a really important point to draw on. And I don't think that's probably as well known as it could be, and it is often, understandably, we're always forward looking in discussions about climate change because it's always about imagining what's happening in the future. But I think reinforcing the idea that yes, we did get a lot of this right, we had anticipated it, and we're talking now on timescales looking backwards that are the same length of the timescales we're looking forwards, right? So if you're thinking about projections that were made in the 1970s about 2020, that's 50 years. We're talking about projections now for 2050, 2070, 2100. That's the same. So sure, there's complexities and things are changing, but as Mike was saying, the basic fundamental physics is kind of the same. It's the socioeconomic stuff that is harder to integrate, and that's actually, I think, another area of really interesting development here is how do you improve the projections of the social and economic trends and integrate those into your climate models and climate projections as well. And there's a bit of work going on in that direction that just goes beyond actual assumptions, but is actually trying to test how those behavioral things play out. But I think emphasizing previous success is a good way to really reinforce the idea that these, even when we say there's uncertainty and these things are hard to confidently predict, we do have the right tools and the right mechanisms for doing it.
I also really liked your idea you presented of admitting mistakes is really important when you do make them. Actually adds to your credibility. It's actually a really good thing to do. And I think that means perhaps correcting mistakes or admitting mistakes and correcting them is really important. And also admitting when some commentary was off and pointing that out and saying, look, this was a silly comment someone made at this point. We admit that. Yeah. I think that's a really important part as well.
Yeah.
We're almost out of time, but I'm going to do it's interesting. This question comes up a lot. People want to know how people in the business, deal with their climate anxiety or worry. And I think in this topic, it is actually really important to sort of thinking about tipping points, how do we deal with the fact that it creates climate anxiety?
I'm happy to take that. I mean, I think the climate anxiety for me is, it's clearly a topic. It's a thing that's being measured. I think it's one of those things where it may be a bit like climate tipping points. It's a term that has entered the discourse ahead of its sort of scientific understanding and basis, and whether we think of it as something which is different from, unique in terms of its symptomology, or whether it is actually something that needs to be treated in the same way that you might treat other forms of anxiety, or whether it's actually quite healthy in that it's focusing people on taking action, I think is important. I mean, my way of dealing with it, I guess, my way of dealing with that concern, that worry, is to do things like this and to be part of setting up this Institute for Climate Risk and Response that we're now running, which is bringing all of these people together to focus on these particular issues. So I think that I personally would not say that I have anxiety or worry. I have concern, but that's partly because of the discussions I have with my clinical psych colleagues, who have a very particular, we've been talking about terminology here, they have a very particular meaning of the term anxiety, what that means clinically, and just putting the word climate in front of it doesn't necessarily make it a distinct, novel concept.
Yeah. Michael, did you want to say anything on that? Because we are out of time. No, okay.
No, that's
So
fine.
thank you so much. Thank you so much for such a fantastic presentation. And thank you to everyone online who have been participating. I recognise that we barely scraped the questions, so thank you so much anyway for your thoughts and engaging in this session. We apologise we haven't got to all questions. I wanted to take this opportunity to thank everyone who's online for supporting the Climate Systems Hub, and to our two speakers as well for giving up their time today. We really hope that you take something from today, be that learnings, connections with others in this space, or if you wish to stay involved in the tipping points discussion, we've got some great webinars lined up for the rest of this year. In June, we are looking at Australia's methane budget with Pep Canadell, and more information will come out around that shortly. If you haven't already, please do register for our monthly newsletter, where you'll find information on upcoming webinars as well as news and science from the Hub, and we'll pop that link in the chat as well. Before we finish, we'd really value your feedback, so please complete our survey, our short survey on how you found today's webinar. That'll be emailed to you with a link to the recording. And then finally, thank you so much to both you, Michael and Ben, and those behind the scenes for making today so successful. And we look forward to seeing you next time.